A bad LLM answer should become a test, not just a log line. LangSmith lets you turn production failures into regression datasets you can run again. This is the setup you'll be able to run after this, which turns a failing trace into tests and runs them as regression checks. I'm Professor Pi, teaching AI engineering and LLM systems with simple Python. LLMs sometimes fail in production. A single bad answer can cost time and user trust. Engineers often stash that failure in logs and forget it. LangSmith helps by capturing runs, inputs, outputs, and feedback, so failures become durable data. Success looks like a small dataset of real failures you can rerun, a baseline that reproduces the bug, and an automated gate that blocks bad changes. You get measurable regressions instead of mystery incidents. At a high level, the idea is simple. Capture failing runs. Turn them into examples with expected answers. Run a baseline and a proposed fix against those examples. Gate releases based on pass rates. Now we will pull recent failing runs from your production project. This snippet fetches recent production failures from LangSmith and counts them. It creates a client, which is the primary LangSmith handle for projects, runs, datasets, and feedback. The variable proj names the production project we want to examine. The function listRuns returns a generator of run objects for that project, which we convert to a list for easy filtering. Each run has an error attribute, so the list comprehension bad selects only those with an error present. The print shows how many distinct failures were observed and provides a tangible signal to act on. A non-zero count confirms you have real failures to convert into tests. Next, we will turn those failures into a reusable dataset for regression checks. This code turns failure traces into a LangSmith dataset you can reuse. The call create dataset makes a new container with a clear description for future readers. The list comprehension pairs extracts a concise input from each failed run by reading the question field from run inputs and attaching a simple expected answer rule. The loop then calls createExample to store each input-output pair under the dataset ID, producing concrete, reproducible test cases. Finally, listExamples confirms how many items the dataset holds. Seeing the example count rise verifies the failures are now durable test assets rather than transient log lines. Now, we will run a simple baseline that reproduces the bug deterministically. This example runs a baseline model against the LangSmith dataset you just built. The RunnableLambda wraps a simple predict function that echoes the question to produce a deterministic baseline. The function runOnDataset orchestrates the evaluation. It pulls inputs from the dataset by name, spins up the chain via the LLM or chain factory, and logs all runs back to LangSmith. The runEvalConfig, with evaluators set to QA, requests an automatic QA-style comparison against the dataset's expected answers. If you add more evaluators, you'll collect richer metrics at the cost of extra compute and latency. The printed count confirms the baseline evaluated all dataset examples. Next, we will evaluate a revised prompt or chain that aims to fix the issue. This snippet evaluates a revised prompt or chain that now cites sources, then compares it with the baseline using LangSmith data. The function predictFixed returns answers including a source tag that signals it used a knowledge base. RunnableLambda builds a tiny chain around that predictor, so it can be exercised the same way as the baseline. The runOnDataset call executes this variant on the same dataset under a new project name, fixedEval, so results stay separate. The helper rate uses client.listRuns to gather outputs for each project and measures how often answers include the word source. A higher fraction indicates better adherence to the policy. The printed comparison quantifies the improvement in citation behavior between variants. Finally, we will apply a regression gate and record the decision so releases are enforceable. This code applies a simple regression gate and records the decision in LangSmith. The variable THR sets the required pass rate, and gate compares the improved variance measured rate R1 against that threshold. The expression nextClient.listRuns fetches a recent run ID from the fixed eval project so we can attach metadata. The call createFeedback writes a regression gate score and a short comment, making the decision visible in LangSmith reports and APIs. Raising the threshold tightens release criteria. Lowering it reduces false blocks. The printed line states whether the deployment passes the gate and which threshold was used. In a real project, this maps directly into your CI pipeline. Failures get pushed to a folder. A test job imports the LangSmith dataset and runs both baseline and candidate, and the gate step fails the build if the candidate falls short. That way, an actual production regression creates a reproducible test that protects users. Recap. What it is: a small pipeline that captures failing runs, turns them into dataset examples, evaluates variance, and records a pass or fail. When to use it: whenever you see unpredictable LLM mistakes and want reproducible checks before deploying fixes. One caveat: automated evaluators are helpful but imperfect, so human review still matters on subtle cases. Next step: scale this by running the same pipeline on a larger corpus of collected failures and add timing and accuracy checks so you measure both correctness and latency under load. If practical AI engineering helps, subscribe and watch the AI engineering videos.